Hello everyone. Today we'll look at the extensions. Extensions are used to add new functionality to an existing type, but they cannot be used to override existing functionality of existing type. So today we'll look at the different ways to extend the functionalities. The first way to look at is to make extension of computed properties. We know that int is the built-in data type of integer, and we want to extend its functionality by providing a computed property of square, which returns the square of itself. Then we can do 4.square, which returns 16. The book provides a pretty useful example of a computed property extension, which extends the double with different length units. So m is meter, returns itself. cm, centimeter, returns self divided by 100. ft, foot, returns self divided by 3.28. So now 1.m, which is 1 meter, is equal to 1, and 1.cm, 1 centimeter, is equal to 0.01 meter. 3 centimeter plus 2 meter plus 45 feet is equal to 15 meters. So this comes in very handy when you have a lot of mathematical calculations. And note that you can do that because double doesn't have a built-in computed property of these properties. So you are not overriding it, you are just adding new functionalities. And another thing to note is that you can only make extension of computed properties. You cannot make extension of stored properties. Now let's look at how to make extension of methods. Again, we'll use the integer as example. We are adding a new method called repeat, which takes a closure as a parameter, and it will execute that closure self amount of times. So if we do 3.repeat println hello, this will call the println hello 3 times. We can also make extension of mutating method. In this example, we are adding a mutating method square to the existing type of double. And what this method does is it computes the square of itself and then assign to itself. So if we have a double d, which is equal to 2, and then we call d.squares, and then the d's value will become 4. Note that d must be a var. If d is a constant, you cannot call the mutating method of squares. Similarly, if you do 2.0.squares, this is a compilation error because 2.0 is a literal, it cannot be modified. Extension by subscripts. For the data type of string, we are adding a new subscript operator which takes an integer as a parameter and returns a character. And what it does is it turns itself into an array and then return the character at the index of I. So if we have a string equals to hello world, string 4 will return O because O is the character at the index of 4. Number 4, extension by convenience initializer. Here we have a structure called temperature, and temperature has a property called Fahrenheit, so that we can create a temperature by doing T equal to temperature Fahrenheit 75. So we are calling the compiler generated member-wise initializer to create the temperature. Now we extend the functionality of the temperature by providing a new convenience initializer which takes a Celsius value as a parameter, and the Fahrenheit is calculated based on the Celsius value. So this is an extension by convenience initializer. Note that you can only make extension of convenience initializer. You cannot make extension of designated initializer. One advantage of using extension for convenience initializer is that you can call compiler-generated initializer within your own initializer. For example, within my own initializer, I can call the compiler-generated member-wise initializer. Usually you cannot do that because once you have defined your own initializer, the compiler-generated initializer is gone. But with the extension, you can do this. Number 5, extension by nested types. First, let's talk about what is a nested type. For example, here we have a class animal, and within the animal we have an enum of habitat. This enum habitat is a nested type of the animal because it is defined inside the animal class. And to use any of the enum value, we have to specify the path to that nested type. So animal.habitat.desert. This is how to use a nested type. Extension can also be made with nested type. Here we are extending animal to have another nested type called attributes. And then we can define a variable which is of the type of animal.attributes. So this is an extension by nested type. And finally, extension by protocol. Here we have a protocol of printable which defines a function printf. And we extend the class of animal to conform to the protocol of printable. And to do that, we have to provide an implementation for the function of printf. This is an extension by protocol. So as a summary, we have talked about 6 types of extensions. Extension by computed properties, extension by methods, by subscripts, by convenience initializers, by nested types, and by protocols. Thank you for watching. Feel free to download the notes from my website and practice with it. See you next time.